Good afternoon. My name is Timeyer Hayter. I am in Module 7, Assignment 7.1, and we're going to go ahead and get started with the instructions. So our overview is we're going to create a brief video with narration describing how to run an ANCOVA in SPSS. We're going to state a research question and a hypotheses, check for assumptions, which is homogeneity of regression slopes and homogeneity of variance. We're going to run an ANCOVA. Interpret the main effect, adjusted mean, and effect size, and then state our conclusion in APA style, and then make sure we discuss the meaningfulness with that. So going into our data, so our research question is there a significant difference between the three classes and test scores when there is 4 control periods missed? Our null hypothesis is there is no significant difference in test scores between the 3 teachers' classes and test scores when there are 4 control periods missed. And then our alternative hypothesis is there is a significant difference in between the 3 teachers' classes when there are 4 periods missed in regards to test scores. Okay. So we're going to go to analyze. We are going to go to univariate. I want the class to be I want the test to be the dependent variable. Class is the fixed factor, and then our covariate is going to be period missed. Okay. We model this. I want full factorial. Well, actually, I want class periods missed, and then I want to add both of these together for our terms. I'm going to click continue, and then I'm going to go down here. I want to make sure class is displayed our means. We're going to compare main effects, and then I want the Bonferroni test for this. And then lastly, I'm going to go to options. I always want these descriptive statistics, but I do want the homogeneity test, and then I'll probably add on the spread versus level plots as well, just for extra detail. So we're going to click OK and see what that comes up with. So here are the 3 teachers as part of our research question. Here's our n value of 30 students, and then here are the descriptive statistics. Okay, but before we get to that, I wanted to go over the Levine's test of equality. So our degrees of freedom is at 2. Our significant value is 0.754. Which that is a insignificant reading because it is greater than 0.05, a lot greater. So the test between subjects effects, we want to focus on class. So we're going to focus on just this row right here. So degrees of freedom for class is 2. The mean is 174.140. And then our significance value is 0.012. All right, so 0.012 is less than 0.05. So that basically means that that significant value is significant. So there is a significant difference in test score somewhere. So that brings us to the estimates, and now we can actually see where those differences lie. So when you look at the actual teachers' classes, we're going to focus on mean for this specific test. So for instance, Smith, the average score is 83.949. Okay. Jones, the average score is just shy of 90. I mean, just shy of 80, so 79.95. And then Brown is a hair over 80, so he's 80.348. So as you can see, there is a significant difference in mean scores especially when you go from Smith to Jones. Jones to Brown, not as much of a difference, but definitely Smith to Jones, there is a significant difference between them. So going to the pairwise comparisons, we can actually break it down further than what we did with the estimates in the chart above. So if you want to look at Smith specifically and compare Smith's class to Jones and Brown, going from Smith to Jones, we have a significant value of 0.04. So that's less than 0.05. So that is a significance there in terms of the difference. But Smith to Brown is 0.08. So it's not as significant as Jones. Smith to Brown. Going to Jones to Smith, so 0.042, that is a significant value between those two scores. But Jones to Brown is a 1, so that is insignificant. And then Brown, we have 0.081, and then that's Brown to Smith, and then Brown to Jones is 1. So both of those are insignificant. So our univariate test, so if we're looking at the contrast between the two, so degrees of freedom is still 2, mean is 142.884, and our significance value is 0.026. So that is definitely a significant difference when we are contrasting using the univariate test. And then here's a plot of the means for those three classes. So as you can kind of see, it kind of gives you a breakdown of how things look, and you can see the discrepancies based off where the plots are in relation to each other on the chart. So this is basically the data here, and it kind of gives you more of a visual, so you can see the distance between them, and that kind of can show you that, hey, there is a significant difference between these three classes. So if I had to break this down, there is a significant difference in test scores when there are 4 control periods missed between Smith, Jones, and Brown. So that means we reject the null hypothesis. We will go to the alternative hypothesis, and that basically shows that Smith's class has a significant difference between Jones and Brown when there are 4 periods, 4 total periods missed. So a real world example of that, if we were to have 4 control periods missed and then compare test scores, there are some other variables you would probably need to look at regarding this, but essentially it shows that there can be several discrepancies that can allude to student scores in these classes. Their instruction can be different. The way the students are feeling at that particular moment can be different, and can be a variable that changes scores. It can be specific periods that were controlled off and thus had a greater effect on one teacher versus the other teacher. So there are some other variables, I would say, that could affect those estimate scores outside of just 4 control classes being off. So I think we would have to keep that in mind if we want to make sure that this data is accurate. Okay, so let me see if that is so we want to run ANCOVA, general unit, covariate, okay, homogeneity of regression. Just want to make sure we touch base on everything. So interpret the main effect, partial n, test between subjects. So just want to make sure I'm not missing anything. Okay, so from the looks of it, just want to make sure I didn't miss anything. From the looks of it, looks like, oh, wrong button. Looks like we touched base on pretty much everything. I just want to make sure I didn't miss anything. So I'm going to change this just to make sure there wasn't anything that was missing in my statistics. So we got Levine's test between subjects. Okay, so we got that. Estimates, pairwise comparison, univariate or spread, and then between subject factor are descriptive statistics. Okay, so all of that has been checked. Okay, so looks like we have covered everything, I believe. So thank you for joining me, and I hope this video was helpful.